Hello, this is Dr. Bahauddin Abdullah. This is the second part of section 11.2 series, and I'd like to devote this video to the geometric series. It's an example, a very important example of series. Well, this is the definition. It is a plus ar plus ar squared plus ar cubed and so on. What do you notice? It starts with A, the first element. It is sum, so it's series, it's not a sequence. But if you consider the sequence, this is A, this is AR. What is the difference between them? AR squared, what's happening? In fact, we are multiplying by R. We are multiplying each term by R. So this is A, AR, R squared, R cubed, and so on. You can write this as summation AR n minus 1 to the power n minus 1 from 1 to infinity. If you put n 1, this would be r to the power 0, which is 1a, you get a, and so on. So this can be written in this form. The first term is important, and the ratio is important. The ratio is r. Well, this series converges under this condition. If absolute value of r is less than 1, if this r is between -1 and 1, half, -1/4, then this series converges, and the sum would be given by this formula. The sum of this series, of the geometric series, if absolute value of r is less than 1, which means r is between -1 and 1, the sum would be a, which is the first term, over 1 minus the ratio, which is r. If absolute value of r is greater than or equal to 1, then it is divergent. Then this geometric series is divergent. Let us take this example. Is this series convergent or divergent? Well, if you look to this series, I have 2 to the power 2n, 3 to the power 1 minus n. How can I write it if it's a geometric series? How can I write it in this form? Well, this is 2 to the power 2n. So I can write it 2 to the power 2 all to the power n. And this is 3 to the power 1 minus n. Can I take it down? Yeah, you can put it down, but you multiply the power by negative. So it would be 3 to the power n minus 1. Instead of 1 minus n, it would be n minus 1. Alright, so the sequence could be written like this. This series, could be written like this. Now this is 4 to the power n. Okay, I need this 4. So I need n minus 1 here. Can you make n minus 1 here? Yeah, 4 to the power n could be written 4 times 4 to the power n minus 1, because the sum would be n. Now I can take 4 over 3 all to the power n minus 1. So this is exactly written in this form. What is the first term? 4. And the ratio, common ratio, is 4 over 3. Look, 4 over 3. Is it less than 1 or greater than 1? It is greater than 1. So this is a geometric series with common ratio greater than 1. So this geometric series is divergent. Another example. Find the value of x for which this series converges. Find the sum of the series for these values of x. Alright. Look to this series. If I want the sum of a series, I just know this rule up to now. And the sum of a geometric series is a over 1 minus r. But the series has to be convergent. I can write this in this form, x minus 2 over 3 all to the power n. If you find the terms, the first term would be, if you put n 0, anything to the power 0 is 1, plus x minus 2 over 3 plus square plus cube and so on. What is the first term? A, which is 1. What is the common ratio? X minus 2 over 3. Because if you divide this by this, any term by the previous term, you will get the common ratio. Okay, so this is a geometric series. It would be convergent when if absolute value of R is less than 1. But R is X minus 2 over 3. So if this absolute value is less than 1, what is the meaning of absolute value less than 1? It means that X minus 2 over 3, which is between, in the middle, is between negative 1 and 1. Now solve this inequality. You must multiply by 3 all terms, so all sides. So you'll have negative 3 here and 3 here and X minus 2 in the middle. And now you just add 2 to all sides. So negative 3 plus 2, negative 1, and 3 plus 2 is 5. So these are the values of X for which this series is convergent. Okay, for these values of X, what is the sum of this series? Well, the rule is A over 1 minus R. So what is A? A is 1. What is R? X minus 2 over 3. So the sum is A over 1 minus R. If you add these two terms, you get 3 minus X plus 2. It will be 5 minus X, and 3 will be in the numerator. So this is the sum of the series. This is another question. Find the sum of this series. Again, sum of a series, I just know sum of geometric series if it is convergent. Well, it would be geometric if we are multiplying by a certain number. Here we are multiplying by 2 over 3. But here we are not multiplying by 2 over 3. So this is not a geometric series. But if you think, if you look carefully, you have 1 over 3, 1 over 27, 1 over 2 for 3. This is in fact 3 to the power 1. This is 3 to the power 3, and this is 3 to the power 5. So if you take these three terms together, you have 1 over 3, 1 over 3, 3, 1 over 3, 5, and so on. And if you take the other one, 2 over 9, plus 2 over 81, plus 2 over 729, this is 3 to the power 6. So we can write this series as sum of two series. Each one of them is geometric. This is geometric. A is 1 over 3, the first term. The common ratio is 1 over 3 square. And this is geometric. The first term is 2 over 9. And the common ratio is 1 over 3 square. If you have two convergent series, their sum would be convergent. Their difference would be convergent. A scalar multiplication would be convergent. So the sum of this series is A over 1 minus R, and the sum of this series would be A over 1 minus R. Adding the two, you get 5 over 8. Now the last question, the one before, this is X 0.99999. What do you think? Do you think that this X, which is 0.999, less than 1 or equal to 1? Well, let us write it like this. We can write it 9 over 10 plus 9 over 100 plus 9 over 1000 and so on. If you add these terms, you will get 0.9999. Now this is a geometric series. What is the first term? 9 over 10. What is the common ratio? Yes, 1 over 10. The common ratio is 1 over 10, so it's convergent. Converges to what? A over 1 minus R. A over 1 minus R. 1 minus 1 over 10 is 9 over 10, so we get 1. So X is 1, so 0.99999 is equal to 1. This is equal to 1, and 1, of course, is 1.000. So there are two decimal representations of 1. 1 is equal to 0.99999, and that's the proof. The last point would be, look to this computation. 0 is 0 plus 0 plus 0. This 0, we can write it 1 minus 1, 1 minus 1, 1 minus 1. to ever, to infinity. Now we will just remove the parentheses. So it would be 1 minus 1 plus 1 minus 1 plus 1 and so on. Now let us take this one first alone, and let us start adding minus 1 plus 1, minus 1 plus 1. If you do that, then minus 1 plus 1 is 0. So this is 1 plus 0 plus 0 plus 0, which is 1. So 0 equals 1. 0 equals 1. What is wrong in this computation? Well, you cannot say 1 minus 1 plus 1 minus 1 plus 1 minus 1 equals to 0 forever. Why? Because this is an infinite series. And you can write it as negative 1 to the power n, isn't it? Put 0 in 0, you get 1. Put 1, you get negative 1. So this is 1 plus minus 1 plus minus 1 forever. This is a geometric series with r equals negative 1. So absolute value of r is 1. So this geometric series is divergent. It's not convergent. So it can't converge to 0. So this sum is not correct. Good luck.